Hi, I'm Lee Patrick Sullivan from Energy Now, and I'm here to explain to you how the three most popular light bulbs work. Let's start with the incandescent light bulb. The modern version of the bulb is credited with being invented by Thomas Edison more than 125 years ago. Let's get small and find out how these things work. That's better. Now, once electricity is applied to these two rods on the side here, it travels up and heats this little piece of metal called a filament. It glows red hot, and that creates light. The filament is made of a metal called tungsten. Tungsten can withstand a lot of heat, which is a good thing because these things get hot, reaching temperatures of 5,000 degrees Fahrenheit. You could fry an egg on this thing. Up to 90% of that energy is wasted through that escaping heat. So why doesn't the filament burn out immediately? Bulbs are skinny on the bottom and fat and round on the top for a reason. The fatty, bulby part allows the heat to spread out over a large surface area. The gas, which is argon in most bulbs these days, does the rest of the heat distribution. Now, compact fluorescent lights, or CFLs, have actually been around in their current form since the 1940s. You probably grew up with these lights in office buildings and hallways in school. The newfangled twisty compact type were designed to fit the millions and millions of corkscrew light sockets around the world. CFLs are a gas discharge lamp, which simply means they use electricity to excite mercury vapor. This vapor produces an ultraviolet light. But when the metallic and rare earth phosphor salt coating smashes into mercury, it fluoresces and creates a light the human eye can see. This light is in a different spectrum than the one created by the incandescent light bulb, and the softness of that light is one of the complaints people have with CFLs. Also, one of the things critics point to is the use of mercury in CFLs. That's why you should never, ever throw out a CFL in the garbage. Please take it to a certified recycling center. And the heat? Well, you can touch a CFL while it's on. By removing the heat portion of creating light, it takes about 85% less energy to light CFLs, and they last up to 8 times longer. And then there are the LEDs, light emitting diodes. You notice I said diodes, plural. That's because just one diode wouldn't produce enough light. So a bunch of them are crammed together to get the brightness we humans need. The technology here is basically a tiny little light bulb that fits into an electrical circuit. But these lights don't use a filament. The light is created by the moving around of electrons in a semiconductor material. Since there is no filament, there is no filament to burn out, making them last a very long time. You've seen LEDs before. They make digital clocks digital. They're used in remote controls to send infrared signals to your TV, and string millions of them together and you get an LED television. In order to create the amount of light necessary, LED technicians borrowed from Edison's 125-year-old technology. They've made a rounded top. This allows for better distribution of light, and like the Edison bulb, it also helped redistribute heat over a larger surface. The LED folks also installed these little fins at the bottom of the lamp, allowing for more heat to escape and take some of the strain off the semiconductors. The result? A bright light that rivals incandescent, uses 85% less energy, and lasts 15 years or longer. I know what you're thinking. More diodes, semiconductors, fins. That sounds expensive. Well, you're right. Most LEDs that you would use in your home run about $50 per bulb. Compare that to the 50 cents you would pay for an incandescent, and it's a no-brainer what the consumer normally would pick.